Hello, everyone. My name is Dominic Ventura with Fourth Axis Design. My business is a design and product development business with consulting for manufacturers and how to apply digital technology to their design and manufacturing. Uh, I have with me today also Chris Glazer, and he's with eLUXE3D. Uh, I'd like to introduce him and also let you see what he does and what the eLux brand of scanners are.
Yes, hello, my name is Chris Glazer, and I am the Vice President of Sales and Marketing for eLUXE3D. We provide jewelry design scanners to the jewelry industry. And yes, we're going to be going over some details as far as stone scanning is concerned. We do have two scanning systems. We have we have three scanning systems. We have two DS3 Gold systems, one with a 50 millimeter field of view and one with a 120 millimeter field of view, as well as the DS3 Silver, which has a 100 millimeter field of view. We're going to be actually demonstrating some stone scanning with the DS3 Silver today, and Dominic will be going over that. So take it away, Dominic.
Okay, very good, Chris. So what I like to do first is show a short video of the scanning process. Well, I'll show you the stones first. So these are the stones that we're going to scan. There was an emerald cut and a Munsteiner style with a carved pavilion. So these are just the different shots of the stones. Right here, the next image is the stones prepped. Now, you have to prep things that are transparent, that have subsurface light scattering, or they are highly reflective. So what we have to do is we coat them. There are different ways of coating it. I happen to use an airbrush system, which I find to be finding a finer control, and it allows me to really fill in areas more accurately when it comes to prepping a model or a stone for scanning. And why we do this is just think of this as a screen for a movie projector. If you're projecting a movie onto stucco, you're not going to get a sharpened image. If you project it onto a nice smooth wall, again, it's a different thing. So by having a nice prepared surface, you're allowing the structured light, which covers the surface, to be measured, to be seen by the cameras. So that's basically the process. So it's just airbrushed on. The wax that I use is just stone layout wax. That wax will not show up in the scanner, and so we kind of use it in a way of masking out as well when we do the editing to take that out. Right now, I'm going to bring the video here, and let's take a look at this. So this is a scanner in action. So what you'll see here is you'll see a series of bands of light that get projected onto the surface. There's stereo cameras in there that look at that with parallax, and they plot a pixel or a point in three-dimensional space on that surface. And that's how it's capturing the data. So it has swing and it has rotate. And by doing this, you're getting full coverage on your part. Now you can also turn the part upside down, and you can do multiple scans. The software then has tools in there in order to stitch it together and create one closed volume. So I'll just close this down, and I want to show you the client software, which is the next thing to demonstrate for you. So this is EasyScan. This is the client software. These are actually two different scans. Let me, this is group. I'm going to turn one of the groups off. That right there are two scans overlapping. So that was the initial scan. You can see where it was anchored to the wax there. I just did two scans in this case. Many times, in most cases, you can just scan a stone with one scan pass, and then you can just patch that hole up, which I'll demonstrate. So we can take these, and there are alignment tools in the software to allow us to do that. In here, there's 1 and 3-point align or manual alignment, and it's very automatic. The algorithm looks at curvature, and you help it along a little bit with your alignment, and then it puts them together into one closed volume. So I'm going to turn off both of these layers, and now this here is this image right here is the actual stone itself, closed up as one volume. So that's the emerald cut stone right there. All right. So what this allows us to do now is take this and we can export this into a CAD program, into a sculpting program, and it'll output either as an OBJ or an STL. So that's the scanning process at that point. And the next thing I'd like to show is how to bring it into Rhino and give you some understanding of how to bring it in and do some editing on that. Okay, Chris, the way I like to continue this demo is to show the import process. These are imports that I did previously. And all I'm going to do now is grab from Windows Explorer, I'm going to grab an Emerald Cut OBJ, slide it over, and I'm going to import that.
So that's the actual STL that you're importing from the scanner.
Right. Well, in this case, Chris, I'm
from
using
EasyScan. I mean, I'm sorry.
Yeah, I'm doing this from EasyScan. Now, in this case, though, I'm using an OBJ. I like OBJs better. Because the problem with STLs is that they're always triangulated into triangles. You know, that's the way it makes it. So with OBJs, it holds quads in many cases. So of course, this is a mesh file. It's coming out of a point cloud, which then creates triangles from this. But if I'm moving things back and forth into ZBrush and back to Rhino, I can actually keep that topology. So so I just brought this in. I moved it over into the 00, world coordinate system at 000, and now it came in with that hole opened up there from the editing process. So I'm just going to highlight that. I'll say Mesh, Repair Tools, and Fill All Holes, and there we went. We just closed that up. And if I shade that in, that's what we have right there. So, that could be smoothed out in other software. You could take this into ZBrush and smooth that out. What's nice about this is that even if you wanted somebody to make this ring by hand, you could print this out and send them the 3D print, and they'd have the stone, and the ring can still be made.
It's an exact replicate. It's basically exact representation of what. There's no more guesswork as far as having to measure or getting a micrometer out or having to take.
Or worse still, Chris, doing it off photographs.
Right.
I do not make anything anymore without having at least a stone scan to work from. I don't want to make it again, and I don't want to have that last minute sweat because something's not fitting properly. So to me, it's just prudent at any given project in order to get it so it's scanned in. So that's basically the process at this point, and it is a good representation of that. Now, in the old days, by the way, we used to use cuttlefish bone, and we used to make impressions of expensive stones, pour in low temperature metal like Babbitt metal or metal that's used in sprinkler systems, and then that replica would be used for the jeweler, and then the stone would go into the safe until the time it was going to be set. So what I'm going to do now is delete that, and let's bring back our other stones here. So what these represent are the scan for the Emerald Cut and for the Munsteiner style pavilion. So there we go with our two scans. One is shaded in, and one is just the triangles that you can see from the scan. So yeah, they're very, very nice, and they're accurate. Now, I'm going to bring up another thing to show you here, which is the an optical scan. Right? So everybody knows about these optical scanners for stones that are on the market. They're also expensive, and they do have some Achilles heels that I'd like to discuss with the viewers. The first thing is that the good thing about the machine is that there are small files. They're 17K, 30K, so they're very tiny. Unfortunately, they cannot do things that have pockets or have the grooves as in the Munsteiner stone, or like a heart shape. So as it's being occluded, it turns around on a little turntable, and as it's turning, the lenses can't see that. It's always being blocked by it, and it's basically looking at profiles and capturing vertices and edges. So if we turn this upside down here, we can see that we captured none of the grooves that are in the Munsteiner style stone. So what the system does on the optical scanner is just basically does a best fit of facets and just covers everything, and that's how it works. So if you're designing something and you want those grooves with a bezel to fit very tightly, you're not going to achieve that with an optical scan, whereas in the scanner from eLUXE, that's very possible.
Well, and I think the other part of that too is, you know, that's limited to just stones, whereas the, you know, eLUXE systems have obviously many more applications, which we'll be going over in some more videos down the road. But everything from, you know, stone scans to helping with wedding bands and, you know, modifying actual pieces of jewelry.
Yes, correct, Chris. Well, I just scanned a number of things yesterday for a customer, and there was a big starfish made out of stone, a couple of jade pieces, which, you know, beautifully carved. You're not going to be able to do anything with that except measure the perimeter of it, and that's pretty much it. So this really allows you to take a stone like that and make a really beautiful mounting for it, knowing that everything's going to fit with no alterations later on on anything. So yeah, it's really important to understand that, you know, the stone scanners or the optical scanners are very, very limited in terms of what they can do, and they're kind of a one-trick pony. We can convert an optical scan to a mesh to NURB, which is something you can do in Rhino automatically. It's a command, mesh to NURB. It's going to take every triangle or poly in there and convert it to a NURB surface, which is then trimmed out. So it bumps it up a little bit more, maybe into a meg or a meg and a half, but it is a NURB surface that can be used for booleans and things of that nature. So that's the good news about it. But again, it is going to be limited on its application in many cases, which leads me to another part of this demonstration, which is about rebuilding stones. So let's hide these off. Let's just back up on that and hide those again. And I'm going to bring up some geometry here to show you the rebuilding process. So right now I have a replica, you know, copy of that stone off to the side with a plane there, and I can move that plane up and down through the stone. And if you notice, I've come up to the table of that, and if I go to the top view, I can see kind of the outline of the table, and I can bring that up or down as I see fit to kind of capture that shape. I'm going to pick a polyline here, and just by eye, to start with, I'm going to go in and trace that table, or the perimeter of the table. We can make adjustments on this later on as well. Now what I'll do in this case is I'll make sure I take vertex off, so I'm not snapping to a vertex, and I can get right to my endpoint there. And now I have my first profile for that. Now that's, of course, that's sitting up a little high because you know, the construction plane. So we're going to do a set point on that, and we'll bring that down to back to that plane. All right. So I can keep doing this, and now I can work onto the second level where now that makes the first facet break there, which is around there. I would do the same thing, and then I would do the same thing at the girdle height, retrace it, and back down here and retrace it. All right. Or you could just take it by control points, just, you know, redistribute them again, make a copy, and move the control points on your curve and do the same exact thing. So what I'll demonstrate here now is that technique of you know, rebuilding from that. So those curves represent what I did on the stone. I'm going to turn it upside down and just do another technique for you, and then I'm going to go to another set of curves next to it and show you how to surface that. So I'm going to use the vertex command again. I'm going to use a polyline. And right here at the top, I'm going to click once. I have another break there. And I have another break right around there. And you can turn this. Again, I use shading in ways that help me look at those edges and lines. So I can, you know, you might not see it in the video, but I can see the edges here. I'll give it one more right there. And now I just created a polyline that gives me, you know, beginning of that facet edge. And I could do the same thing here on this side. So I'm going to capture that here as well. Here and down, right down to the bottom. So that's how you can go in now and you just capture edges. And by capturing edges, I'm going to move over to this right here. By capturing edges, now we can use lofts, simple lofts, and just go in and loft that and create my first couple of facets. I can do the same thing on this one here. And if I go onto the top curves, again, those are all closed, and we're going to get a nice girdle and crown for the stone, just based on a few curves, capturing that. Now again, this is not necessary. It really depends on how you like to work. You can easily work with the mesh and not worry about it. You can take accurate measurements off of it. You can take profiles. There's a thing called the section command in Rhino. So if I want to, let me just slide this over just briefly. If I say section now, and I grab that object, I can actually go across, and I can create cross sections or profiles for this as well. So I'm going to go back into the perspective to show you how it's working. It works off the construction plane. Now again, this is not necessarily how you would do this. I'm just demonstrating how to capture some information. Remember again that these are...
Moral of the story is there's many ways to leverage the data.
Yeah, keep in mind, Chris, that these are polylines as well. So if you want to go in there and you want to turn on the control points for this, you can see where there's a lot. So you
have to rebuild those curves.
Right, and which is simple to do with either a NURBS or a polyline command. But let's bring this back into position here, and I'm just going to overlay it just to show you a little more editing on a stone. Well, let's get rid of this other geometry. What I'll show you now is finally the final stone right here, and I can now go in. I'm going to lock the stone. I can now go in, and I have two ways of editing this to get it even closer to the stone. I can either turn on the control points again, and of the curves themselves, and then using the vertex command, I can snap to a new vertex or a new location, and edit the stone that way. So you can use your original curves if you use history when you're using Rhino. That's one way of editing this. The other way of editing it is to go into a thing called what that does. Solid point down does it actually gives you the ability of editing a closed poly surface, or even or a poly surface in general. So now I have these points here. This is the actual poly surface that you can go in and edit as well. So let's just grab all the control points on top, or the poly points, and we can move those up and down, and we can also edit that way. So this is what I rebuilt from the original scan. So this is what we end up with here. There's our original scan, and there's our restructured stone. Again, this is a lot more accurate than trying to do it from photographs. It won't be the stone, but you'll know the extents of what you have to do in terms of making anything that's a hold the stone in, whether it's bezels or prongs or anything like that, under bezels for holding the pavilion. So I find it, I use the stones in the mesh format most of the time when I can, and it's in rare instances that I'll go in and I'll extract out for seats or things like that. Generally speaking, the setters that I work with like to cut their own seats and like to do the work themselves. So it's really up to the individual in terms of what their manufacturing process dictates. But that's kind of in a nutshell, Chris, as far as bringing stones in and doing some scanning with them.
Yeah, those. So you could also use the. What about rendering? Possibly, I know I've had people ask me a little bit about rendering, and you can, basically use the rebuilt stone as as an item that you could use in a rendering.
You can. I mean, again, the downside, or not the downside, but one of the things that you have to look at with the eLUXE scanners is that it's based on points. And so think about drawing a line on a piece of paper, a black piece of paper. There's a white line, and then sprinkling salt on that, so that so you're going to hit the line with some points, and in some cases you're not going to hit that line. So whereas the optical scanner is basically doing it by capturing the edges, we have to capture general data to get that. So as far as how the stone looks, you can go into ZBrush and actually get that stone so it's sharp again. But it'll have a little rounding in the rendering, unfortunately. It's not going to be as sharp.
I see.
Yeah. But there are ways of sharpening it up or just rebuilding it. My feeling about this is that here's the thing: you can take any stone that's a closed volume as long as it's NURBS, and you can edit it like this and just match it to any stone you scan in. If it's a standard stone. So if you have a standard emerald cut, I don't have to remake it every single time. I can literally pull the points to the new stone scanned in, and then I have another emerald cut in a different size.
I got it.
So here's an example. Let's take this stone here, and I'm going to hide everything else. And let's just move this here, and I'm going to just show you quickly. Let's go into solid points on again. So I can literally go in here and just grab one whole side of this and stretch it out if I want to, and create a different shaped stone. All right, now I'd have to go in here and play around with the bottom points as well, but that's something that you can do and give yourself a whole nother stone in itself, or edit it by pulling the stone. So I'm just going to pull these out a little bit here, and then I'm going to go to the bottom, and let's grab the center like this. So I just grab a planar set of stones. I'm going to use a scale command, and let's go between 2 points so we can get it centered. And now I can pull that out a little bit, and I've just re-edited that stone. So once a stone is created, you can do a lot with it in a NURBS format and reuse it if you have to. Just bring a new stone in. You can do this with pear shapes. You can do this. You're not going to put every facet in. I don't think it's necessary. Again, you want to get general geometry, but there's a lot of ways of leveraging that data and then editing it later so that you can actually capitalize on previous efforts with the scanning itself and the rebuilding.
Yeah, well, we're starting to find now is that a lot of folks that have very odd shaped, non-conforming type stones really like the system just because it alleviates all the guesswork.
It really does, and I've had many disappointments where there's last minute fixing or changing or cutting things away because the bellies of stones are way too big. And just grabbing something out of a CAD program is just not going to do it anymore. So I would never make a ring by hand when I used to do it in the old days by not having 3 stones in front of me to make that ring. So it's really no different when you're doing things digitally. So this just ensures that you have accurate data, and the better the data, the better your product is going to come out.
Yep, very much so.
Okay, so I think that wraps it up, Chris.
Yeah, I think so. Very nice demonstration, Dominic. I really appreciate your time and effort and showing the folks how you're leveraging eLUXE3D scan data. We're going to be doing a series of these videos for different applications. So we're going to be trying to put something out here in the next, try to do them every week, every 2 weeks, just different applications from how to do custom wedding bands to just special projects, unique projects that, might make you think a little bit outside the box on how scanning would be able to help you in your jewelry business. So if you want to bring up that eLUXE slide one more time, just so people can see our email addresses and our names, we'll leave with that in closing. And
yeah, sure. Well, the last thing I'd like to say too, Chris, is that in terms of what's coming up on these demos, I have one on a link which was completely scanned in and rebuilt using Rhino and ZBrush with very little change in outside geometry. I also have one on a ring that was reconstructed. So I'm getting those together, and we will certainly look forward to being able to demonstrate these things and show how I use it on my business on a daily basis. It's a tool that I cannot do without at this point.
Yep. Well, and it's becoming quite common with anybody who's doing custom design. You have customers bringing all kinds of different ideas to the forefront, and if you can save time by, bringing something, a physical object that you don't have to model from the ground up into your CAD program, it really does speed up the whole process. So, as you can see, you got myself, Chris Glazer, C Glazer at eLUXE3D.com, as well as Dominic Ventura, Dominic at fourthaccessdesign.com. Feel free to email or contact us if you guys have any questions, and there is some more information on the scanners at eLUXE3D.com. So thank you again, Dominic, and we'll see you folks soon.
Great. Thanks, Chris. Bye-bye.